Now, life is constantly projecting into and integrating out of form in creation. There are natural rates of expansion and contraction. The crystal spiral is associated with the Katara grid, and it illustrates the emergence from the center of the Katara grid, expansion into creation, contraction out of creation, and a return to wholeness in source. Now, the progression of the Katara grid is that the 9 of the current stage matches the 12 of the previous stage, or alternatively, the 6 of the current stage matches the 12 of 2 stages prior. Now we'll just show an animation of the crystal spiral. Now we have the inbreath, where dimensional structure contracts out of creation and returns to the wholeness of source. In other words, it expands back into pure consciousness. Now, the emergence then comes as the outbreath, where creation is projected out into expression, into dimensional structure, emerges progressively, expanding outwards to its full extent. Now, in-breath and out-breath, expansion and contraction are relative terms. Expansion into creation represents a contraction of consciousness, and conversely, creation contracting out of form and expanding into wholeness in source is an expansion. Now we can illustrate these stages, the crystal spiral here. The 12 of the prior stage corresponds to the 9 position of the current stage. And if we go to stage prior, the 12 of the stage, two stages back, corresponds to the 6 of the current position, of the current state of expansion, and so on. So we go, in terms of progression, we go through 12, 9, 6, 5, and then we go all the way, spiral all the way back into the center, and conversely the other way when we're coming outwards. So in terms of, we'll just expand this fully again. So the key ratios involved in the crystal spiral then are, for a 90-degree rotation, in other words from position 6 up to position 12, there's an expansion by a ratio of 2. So that 2-to-1 ratio is important. It ties in with the proportions of the Katara grid, 2-to-1 proportions of the Katara grid. Likewise, the progression from 5 out to 6 is a 90-degree rotation involving a ratio, an expansion or a contraction by a factor of 2. Now the 9 at a 45-degree angle represents an intermediate stage between the 90 degrees. The 90 degrees are important because they are the quadrants, and the quadrants are what give independence in dimensional structure. So the 90 degree is important, and the ratio for moving through 90 degrees on a crystal spiral is 2-to-1. And then the root 2 arises as an intermediate stage of expansion between the 9 between 6 and 12. Now, key features of the crystal spiral are that the crystal spiral has a well-defined and meaningful center. In other words, the center at the core is of major importance. It's where it expands into and out of, where life emerges from the core, from core consciousness, and expands into creation, and the doorway through which it returns, where form contracts and life expands back into the wholeness of source. Now, each dimensional center has relationship with the core center at every stage. In other words, at every stage of expansion, dimensional center has relationship with the core center. So there's a high level of connection throughout the crystal spiral at every stage of expansion, and even within the Katara grid itself that represents dimensional structure, there's a high level of connection. Also, there's a symmetry and balance. In other words, the rotation is balanced around the center point, and the points are within the Katara grid are integrated and balanced around the center. Dimensional structure in turn creates more sophisticated universal structure. The 12 dimensions of the matter fields are represented by the 12 centers in the Katara grid. However, we have further 3 dimensions associated with the primal light fields in creation, which are dimensionalized. We also have 3 levels of the primal sound fields, which are non-dimensionalized, but they are still represented within the Katara grid. So we have a further Katara grid with its 12 centers corresponding to the primal light and sound fields, again spanning 12 centers, and the 2 together span the complete range of levels in creation, from matter through light and sound. and integrating all the way to the source. So full spread of levels in creation are represented by two 12-center Katara grids, making up a total of 24 centers. Now we have the matter fields represented by the lower Katara grid. Now the matter in itself is a polarity, and is associated with polar opposite with antimatter. So this whole structure is replicated in a parallel structure. This configuration is represented over here. We have the matter fields corresponding to the E-ray polarity, and we have the corresponding antimatter fields corresponding to man-A polarity. And in full expansion, these phase at 90 degrees to each other. And each of those has their corresponding primal light and sound fields for the ray matter side and for the man-A antimatter side. They all phase, as they expand, they phase at 90 degrees to each other. They effectively spread out like the petals of a flower. Now we have an additional structure, a new structure now at the center of this configuration. This is called the Veca core, the Veca inner core of this particular universal structure. The quadrants corresponding to the four Katara grids are referred to as Veca quadrants, Veca grids. The inner Veca core then carries the Manu polarity for the whole structure, for the E-ray on this side and for the Man-A on the opposite side. Now this is an additional Katara grid with its 12 centers. Actually there are two Katara grids overlaid each other, making up a total of 24 Katara centers. But we're primarily interested in the location and the configuration of this inner Veca core. Now this core sits right at the center of the four grids, the four Veca quadrants, and it is the center for the whole structure. Now this illustrates the importance of the 12 centers. The 12 centers for both of the matter grids and the 13 centers for the primal grids all coincide with this center. So this illustrates the importance of these 12 center grids as key connection points. In other words, they are the connection points up to the next level in structure, in universal structure. They're the key connection points of all of the four Veca Katara grids. They coincide with the central core of the whole universal structure. Now we can illustrate the phasing process for this universal structure with an animation. This diagram is a repeat of the former diagram. We have the four Veca quadrants, the pink or violet representing the E-ray side, the yellow representing the Man-A side, the Man-A polarity, and the Manu is represented by the Veca core. We have the matter fields here and the primal light fields here. Now we introduce an additional superstructure here. This is an outer Katara grid called the Akasha. So this is the superstructure that carries the whole configuration of universal structure. The Akasha is closely associated with the inner Veca core. The two together, they host the Veca quadrants that form the universal structure. So we can set the animation in motion to illustrate the phasing process. The return to source, and now the emergence into creative expression. Now this model of universal structure can repeat within itself, generating progressively more detailed levels of structure within itself. In other words, it can progress down through a number of different levels. So in this diagram, again, we have the Akasha, the outer Akasha, the superstructure for the particular universal structure. We have the inner Veca core, and between the two, they birth four quadrants, each of them a Katara grid. Now, each of these Katara grids in turn can become an Akasha for the next level down. So each of these grids can form an Akasha with a Veca core in the center, and that configuration can birth additional quadrants, more detailed quadrants at the next lower level in this universal structure. Furthermore, each of these Akashas in turn, these Veca quadrants, can become an Akasha, generate a Veca core, and spurt a sequence of Veca quadrants within its own space. So this is a recursive structure. It can generate multiple levels of structure within itself. Now, a further point of interest is the role that the Krystal spiral plays within this universal structure. All the elements of the structure are in Krystal spiral proportion and alignment. So if we take the Veca core and its Akasha, a set of Krystal spirals will emerge from the Veca core, from the center of the structure through the Veca, and they will expand out to encompass the outer Akasha. Now, four crystal spirals emerge, we say the primary crystal spiral associated with the inner Veca would come out here in green and expand out here to embrace the outer Veca, or around the perimeter of the outer Veca. Now, a counterpart spiral can also emerge from the other side and come out this way and frame the outer Veca, or complete the framing of the outer Veca, and the same can repeat for the other side. So we have 4 crystal spirals emerging from the core of the structure, framing the inner Veca, and in turn expanding out through the Veca quadrants and framing the outer Veca, illustrating the crystal spiral portion between the inner Veca and the outer Veca. Now, a further point of importance is that 4 crystal spirals passing out through the Veca quadrants, they actually pass right through the centers of each of the Veca quadrants. Out here, 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 and here. Now, as these crystal spirals pass through the core of each of these Veca quadrants, the center point of each Veca quadrant, they in turn spark a crystal spiral flow in centers of each of those Veca quadrants. And this in turn generates a sequence of 4 spirals propagating out through the framework of that particular Veca quadrant. So each primary crystal spiral sparks and births a sequence of crystal spirals propagating through the structure and the next level down. And each of those crystal spirals, each of those 4 crystal spirals propagating through the Veca quadrant, which is now forming a element of a universe at the next level down in the universal structure. So each of those again passes through the center of their local Vecas, and they in turn can generate or can spark an additional sequence of spirals propagating through the Katara grids below them. So this illustrates crystal spirals serves a role not only in proportioning the expansion and contraction of these universal structures, but they also connect the structures. They can interconnect all of the centers of the structures with the core. Like we say, the primary crystal spirals connect the Veca cores, they connect the Veca core, and they frame both the Veca and the Akasha. So they connect all of the primary connection points within this universal structure. And secondly, they form a distribution system within the structure. So they allow for the propagation of influences from the core out through each of the quadrants, down through the quadrants to the next level of structure below them. And that influence then can be propagated to the next level down and progressively to the next level down again, more detailed level down in universal structure. So they form a system of circulation and a system of connection down through the structures and all the way back up again. So they preserve the integrity of connection through this universal structure, all the way from the core, from the pure conscious connection, the connection with pure consciousness in the core, all the way out to every level of expression in creation. Now, there are many different forms of spirals, and spirals can have many different ratios of expansion and contraction. In this crystal spiral that we've been discussing so far, the ratio of expansion and contraction for every 90 degrees of rotation was 2. Now, there's another important ratio associated with spirals, and that's the golden mean. The golden mean is defined as follows. If we take a line and we divide that line in a certain proportion such that the ratio of the smaller to the larger portion is equal to the larger portion to the total line section, or conversely, the whole of the line in relation to the bigger portion is the same ratio as the bigger portion is to the smaller portion. Now we can express that mathematically and we can solve it. We come up with a particular ratio, the ratio between the larger portion and the smaller portion, and the ratio between the total and the bigger portion is denoted by a Greek letter called phi. And it's very easy to work out the mathematics of this. It's relatively straightforward, and it comes out to a value of a number of 1.618. It's an infinite decimal that goes on forever. In more exact terms, it's represented by this mathematical expression here, the square root of 5 plus 1 over 2. That completely defines this golden mean ratio. Now, we can interpret that geometrically. We can convert that into a geometrical form as follows. If we take any rectangle that's in the proportion 2 to 1, and we draw a diagonal on it, we can apply the Pythagorean theorem to determine the length of that diagonal. It's equal to the square root of the sum of the squares on the other two sides. It's equal to 4 plus 1, 5, the square root of 5. So here we have the square root of 5, here we have 1, and here we have 2. We have all the elements of the phi ratio. Phi ratio then is geometrically equivalent to that, the diagonal on this with one rectangle, plus the shorter side over the longer side. So that gives it a very accurate definition of this golden mean ratio, and it gives a very simple geometric process to derive it. In other words, we can represent it geometrically with absolute exactness. Now, this ratio phi equals 1.618 is composed as follows. Two elements, it has 1 and 0.618. Phi then is equal to 1, and this 0.618 is actually 1 over phi. So phi is equal to 1 plus 1 over phi. In other words, 1.618 is equal to 1 plus 0.618. Now, if we multiply across by phi, we get phi squared equal to 1 plus phi. So this gives us a tool for simplifying expressions, which we will use further on. Now, phi is heavily associated with 5 and is present in all 5-sided figures, such as the pentagon, the pentagram, pentacle, and so on. In other words, it's inherent to, and it is the foundation for, pentagonal geometry. Wherever we have pentagonal geometry based on 5, we have the golden mean ratio deeply embedded there. And in fact, it is a key element in the foundation for all pentagonal geometries. In other words, to geometrically draw a pentagon, we need the phi ratio. When we have the phi ratio, we can draw any of the pentagonal elements, the pentagon, pentacle, and so on. Now, it's also heavily associated with 5. It's also associated with dimension 5, and this is of significance, as we'll see further on. Now, embedded in the definition of this ratio is that each element is the sum of the previous two. In other words, the total length of this line is equal to the sum of the two inner portions. So this is baked into the definition of phi. In other words, wherever we have something equal to the sum of the previous two terms, the ratio involved is phi. So in any number sequence where each number is the sum of the previous two elements, the numbers will fall into phi ratio and vice versa. So this is a characteristic that defines phi. So there are two features associated with phi. One is that it's associated with pentagonal geometry, and the second is that every element is the sum of the previous two. Golden mean ratio, it's a natural number, it's a legitimate mathematical number, and it is natural, and it has interesting mathematical characteristics. And it does arise in structures associated with Keylontic sciences, among other things. Now, if we look at the symbol associated with the monad, this is an important symbol or geometric structure within KS. The phi ratio is actually embedded within this structure. We have the outer circle around the symbol, and we have a radius associated with that going out to A. Now, there are a number of squares here, and these squares are divided into two, so that we have rectangles here in the proportion 2 to 1. In other words, that there is in the proportion of 2 to 1. So, for example, if that is 1, then this is a half. This is root 5 over 2. And that plus that divided by that is in phi ratio. That is equal to that. So, the radius then of the big circle is phi times the diameter of the intermediate size circles. In other words, the radius of the big large circumscribing circle is equal to 2 phi times the radius of the intermediate circles. Also, within the Katara grid, again, we have the 2 to 1 proportion of the Katara grid, and we have 2 to 1 ratio present within the Katara grid. So we have squares here within the Katara grid, and these squares are divided in two. So again, if this is of length 1, this is length half, this is root 5 over 2, that plus that divided by that is in phi ratio. Now that's equal to that. So distance here from 3 to 5 to A is in phi ratio with the distance from 3 to B. Now it's not quite as strong as in the monad, but it's still there and it can be found in these structures. Now we developed the golden mean ratio and put the work as follows. We start by taking a square of side unit length. We divide one of the sides in half, and we draw a diagonal from the midpoint to one of the opposite corners. This gives us this red diagonal here. Now this red diagonal plus one of the halved sides is equal to phi. It's geometrically exactly equal to phi. So all we have to do is to rotate this diagonal horizontally onto the baseline, such that the baseline now extends from A to E, and the line AE is an exact representation, geometric representation of phi. So now this provides us with a new geometric structure called the golden rectangle. This is a rectangle in proportion side 1 to phi 1.618, a golden rectangle. Now this contains two elements. It contains the original square that we started out with, and it additionally contains a small golden rectangle in the large golden rectangle. So the large golden rectangle now is equal to the sum of the square plus the small golden rectangle. Now we can develop this further by drawing a new square on the long side of the golden rectangle. So we can take a golden rectangle as shown, and we can erect a square on the long end of that, and that creates a new golden rectangle, which is 1.618 or 5 times bigger than the previous one. And we continue this process, progressively adding squares to the long end of each golden rectangle to create a new golden rectangle. And in doing so, we trace out a spiral, a new spiral called the golden mean spiral. So we will illustrate that now. That illustrates both contraction and the expansion phases of the spiral. Now, the spiral has a fixed center. This center corresponds to the center around which all of the golden rectangles are rotating. In other words, there's a fixed point within the whole construct that all of the golden rectangles rotate about, and that's defined here. And we get this fixed center point by drawing diagonals on the golden rectangles. So if we take any two golden rectangles and draw the diagonals, they will intersect at a point here. Now, all the diagonals will lie along these directions. All the diagonals for every golden rectangle in the sequence will lie along these lines here. And so these lines define radii for the spiral. In other words, starting from the center, we have radii expanding outwards. We'll say this is the first one that's illustrated clearly here. We go from here, rotate through 90 degrees out to this position, rotate by 90 degrees to this position, rotate by 90 degrees to this position, and forward 90 degrees to this position. Now, each radius is the golden ratio proportion bigger than the previous one. So there's a progressive increase by the golden mean proportion from one stage to the next as the spiral rotates through 90 degrees. Now, in between 90 degrees, there can be half stages of expansion, and these will correspond to the square root of phi, the square root of the golden mean ratio. So in going from 90 degrees, the radii or the spiral increases by the golden mean proportion. Going halfway through 90 degrees would increase by the square root of golden mean proportion. There are a couple of things we noted about this spiral. The first major point we noted is that the spiral is rotating by a center that is asymmetrical. It's not balanced within the structure, within the golden rectangles. In other words, it's off center quite a bit. So the geometric center of a golden rectangle would be here, for example. The center of rotation is quite a bit off that. Now, this creates a certain tension between the center of rotation and the geometric centers of the golden mean rectangles. Now, wherever we have a body rotating about an asymmetrical point, in other words, a point that's not symmetrical within the body, this sets up a tension, which in turn creates vibration within the body. So if we take, for example, the wheel of a car, if there's too much weight on one side of the wheel in relation to the other side, this will create a vibration, a thump, thump, thump vibration, that over time will do some damage to the car. So that is a significant point to be noted, is that the center of rotation for the golden mean spiral is quite asymmetrical. It's off center, and this creates a certain amount of unbalance in the construct. Second point to note is that the squares as elements within the golden rectangles are progressively isolated from the center. In other words, they don't have direct relationship with the center. They don't have direct connection to the center or direct relationship with the center. Now we'll take a quick dive into some of the mathematics of the golden mean spiral, and please feel free to skip over this if it's a bit too detailed. Now, the golden mean spiral progresses by increasing powers of phi, where phi is the golden mean ratio, as follows. So we start with 0, 1, and then phi, and then increasing powers of phi. In other words, we increase by phi through each step. Now, between 0 and 1, there's an internal spiral where the reverse happens, where instead of increasing by powers of phi, going from 1 back to 0, we have progressively decreasing powers of phi. In other words, 1 over phi, 1 over phi squared, 1 over phi cubed, all the way down to 0. So the golden mean spiral has an internal spiral, which is represented by the gap between 0 and 1. Now, we're dealing with powers of phi here. Now, we can simplify those using the expression that phi squared is equal to 1 plus phi. And that can be used to reduce the powers of phi as follows. So, for example, we can take this element here, the phi squared, and we can replace that by 1 plus phi. Now the next element up from that is phi times bigger again. So we just multiply that by phi and we get phi plus phi squared. Again we can replace the phi squared by 1 plus phi. We get 1 plus 2 phi. Apply that by phi and we get 1 plus 2 phi squared. And again we can replace the phi squared and we get 2 plus 3 phi. So we get this progression. Instead of dealing with directly with powers of phi, we're dealing with these numbers, multiples of the basic golden spiral ratio, or the golden mean ratio phi. This illustrates that there's a number sequence embedded within the golden mean spiral. In other words, there's a number sequence as follows. It's starting with 0 and it goes 1, 1, 2, 3, 5, 8, 13. And it's repeated on both sides of the terms. In other words, we have 1, 1, 2, 3, 5 in the units. Then the multiples of phi are again 1, 1, 2, 3, 5, 8, 13, and so on, up along. Now this is referred to as the Fibonacci number sequence. And like the golden mean spiral, it has the property that every term is the sum of the previous two terms. And it can also be proven that the ratio between terms progressively approaches phi. So initially the ratios between successive terms are not phi. In other words, between 1 and 1, the ratio obviously is 1. Between 2 and 1 is obviously 2. Between 3 and 2 is obviously 1.5. But it does progressively converge towards the golden mean proportion, the golden mean ratio of 1.618 and so on. Now, in general, any number sequence where each term is the sum of the previous two will approach the phi ratio between terms. And we can illustrate this with arbitrary numbers, a and b, as follows. So if we start out with any two numbers, a and b, these could be 47, 105, or whatever. We add them in pairs. The next term after a and b is a plus b. And then the next term after that is a plus b, which is a plus 2b. And then again, add the previous two terms, we get 2a plus 3b. Add the previous two terms, we get 3a plus 5b. Continue with that process. Now we can see that here again, we're getting the same Fibonacci number sequence. The 1, 1, 2, 3, 5, 8, 13, and so on. The Fibonacci number sequence is embedded in any sequence where each number is sum of the previous two. Now we can prove that where we take a sequence where we're adding, where every term is the sum of the previous two, we can prove that the ratio between terms approaches phi. There's an outline of a proof there, but we won't go into it. Now this Fibonacci number sequence can also be used to generate a spiral based on the phi ratio. And just as the Fibonacci number sequence itself is embedded in the golden mean number sequence, the geometry for the Fibonacci spiral is also embedded in the geometry for the golden mean spiral. And we can derive it as follows. If we take a golden mean rectangle to generate a golden mean spiral, it'll have a center, GM, as indicated here. Now if we section this larger golden mean rectangle at that point, we get a new, smaller golden mean rectangle. A scaled down golden mean rectangle is a replica of the original golden mean rectangle, but scaled down by this factor here, which we can derive mathematically. This gives us a new scaled down golden mean rectangle, which provides a geometry for the Fibonacci spiral. Now we can take this Fibonacci rectangle and we can divide it into its square and its internal smaller Fibonacci rectangle. And we can section that rectangle again, just draw a diagonal to derive a center within that Fibonacci rectangle. So we get a new center, a Fibonacci center. Now this Fibonacci center is the center, geometric center within the Fibonacci rectangle for the Fibonacci spiral. So the Fibonacci spiral uses this fib center for its spiral. An important point to note is that the fib center is much more centered in the original golden mean rectangle than the golden mean center itself. We can now illustrate the Fibonacci spiral in both its contraction and expansion phases. Now we can bring the three spirals together for comparison. We can draw them with a common center to a common scale as illustrated in this diagram here. We have the Krystal spiral illustrated in blue, the golden mean spiral in violet, and the Fibonacci spiral in red. Now it's important to note that all of these spirals have a fixed center, and there are radii coming out from this fixed center to each point on any one of the spirals. This radius expands or contracts at a continuous rate. In other words, it expands or contracts uniformly with progression or contraction of the spiral. This is an important point because sometimes these spirals are drawn manually as a sequence of circular arcs. Now the problem with that is that these circular arcs have their centers in different locations. In other words, the center isn't constant, and also the radii don't vary uniformly. They go up or down in a stair-step fashion. So it's an approximate technique for manual purposes, but it's not an accurate representation of the true nature of the spirals. Now, the spirals are described by relatively straightforward mathematical formulae, and it's relatively easy to use mathematical tools to represent them quite accurately. Now, Krystal spiral and the golden mean spiral are referred to as exponential spirals. Exponential simply means repetitive multiplication. In other words, they expand, the radii expand by progressive multiplication. So for the Krystal spiral, for every 90 degrees of rotation, it's increasing by a factor of 2. In other words, we have repetitive multiplication. And for the golden mean spiral, we have repetitive multiplication by the factor of 5. Krystal and golden mean spirals are fully formed spirals. On the contraction phase, they cycle progressively and contract into their point of origin in 0. In other words, these two spirals have internal spirals of contraction that connect the point 1 to 0. Now, the Fibonacci spiral doesn't have this internal spiral. It doesn't have a direct relation between 1 and 0. The process for generating the Fibonacci spiral is unstable between 1 and 0, and it creates unstable oscillation between 1 and 0. So it doesn't have this direct relationship with its point of origin and source. The Fibonacci spiral is effectively a derived spiral. It derives from other spirals such as the golden mean spiral, or in some cases the Krystal spiral. So Fibonacci spiral then doesn't have an internal spiral. It's an approximate spiral in its early stages, and as it expands, it approximates to a scaled down version of the golden mean spiral. All of these spirals pass through the point 1. Now, for the Krystal spiral and the golden mean spiral, they cross over each other at the point 1. The Fibonacci spiral touches both of these spirals at the point 1, but the Fibonacci spiral never actually crosses the other two spirals. The only way a Fibonacci spiral can cross a Krystal spiral or a golden mean spiral is by one of or more of the following. One of the options is to counter-rotate against the spiral, to have a different center, or by being artificially inflated in an explained process. In other words, this is the only way that the Fibonacci spiral can cross one of the other two spirals. Now we can look at the number sequences associated with these spirals. In the case of the Fibonacci and the golden mean spirals, every number is the sum of the previous two. In other words, it connects to the previous two only. Now, this is illustrated in this sequence of progressive expansion of numbers here. In other words, every number is the sum of the previous two only, and it doesn't embrace the history of the earlier elements, and doesn't hold direct connection back to its point of origin in 0. Now, what would happen if we, instead of adding 2 numbers, we added a larger number of numbers, 3 numbers, 4 numbers, and so on? We would get progressively greater ratios between the terms. Now, what would happen if we used all of the previous numbers? In other words, if we added all of the previous numbers in the number sequence. In this case, we get the Krystal spiral sequence. In other words, as we add all the numbers, every element in the Krystal spiral is the sum of all the prior elements plus unity. Now, this unity is important. This unity represents the internal spiral connection between 1 and 0. In other words, as we progress from 4 to 2 to 1, the next stage of progression then is down to a half. We divide by 2. We divide by 2 again to a quarter, by 2 again to an 8, to a 16th, and so on. Now, if we take these elements in the internal spiral and we add them together, they sum to 1. Notice that all the elements on the internal spiral sum to 1. The internal spiral is then represented by the presence of unity in this sequence here. So this means that every element on the Krystal spiral encompasses all the previous elements plus all the elements in the internal spiral, connecting all the way into 0. In other words, the Krystal spiral uniquely holds connection through all the previous stages to its point of origin in 0, and it also preserves all the prior history. This degree of connection and alignment between stages becomes important a little further on when we look at the question of harmonics. When we look at the structure of a spiral, we can see why it's such an important symbol within creation. It combines two of the most fundamental processes in creation. It combines the process of oscillation and of growth and decay. Now, circular motion is associated with oscillation and frequency. In other words, if we look at the circle and we consider a radius, one of the arms of the circle, rotating continuously, the shadow of that rotating arm will oscillate up and down on the axis. And in doing so, it will create a wave pattern. Now, this wave pattern creates oscillation and frequency. In other words, the frequency is associated with how fast or how slow the cyclic process is rotating, and the waveforms are associated with frequency. Circular motion is associated with radii that are of uniform length. Now, if in addition to the rotation we allow the radii to either expand or contract, we get a spiral. In other words, take circular motion, let radii grow or decline as they rotate, and we have a spiral. So we can see this represented here as the spiral rotates in a clockwise direction. We have the radii expanding out in a consistent way. There is progressive increase in the radii as the rotation occurs. Conversely, if we rotate in the opposite direction, there is progressive reduction of the radii. They converge progressively to the point of origin, to their center